Hi guys, and welcome again to HSC Chemistry and Chemical Monitoring and Management Topic 3, and this is video number 13 on atmospheric pollutants. In this particular video, we're going to look, I think, specifically at the sorts of pollutants that are present in the lower atmosphere, so in the troposphere. So we looked in the last video at the different layers in the atmosphere, and so now we want to just concentrate on some of the atmospheric pollutants in the troposphere. Pollutants come from both natural and human activity sources, and so it's important that you know some examples from both. And of course, when we were looking at the oxides of both sulfur and nitrogen in the acidic environment topic, that was giving you already a bit of a taste of the sort of substances that can get into the upper atmosphere and the sort of consequences that can happen when they do. It also, at that point, we started to look at some of the sources as well. So we know that volcanic activity, for example, can produce sulfur, and in that very high temperature environment, the sulfur can become a sulfur dioxide or sulfur trioxide, one of the SOXs. And of course, we know that that can also be a contributor to acid rain. And likewise, lightning is also a natural source of nitrous oxides, nitrogen combining with oxygen, and they form different types of nitrous oxides, NOxes, and possibly even the formation of some ozone. Now, ozone is fantastic in the stratosphere. It's not so good in the troposphere, so we want to try and avoid that wherever possible. One of the things that's useful is to give yourself a little bit of a table, just I guess a bit of an overview of some of the important pollutants. So particulates is something that you'll see a lot. One of the most common particulates is soot. So when you burn toast, you get that little black smoke. That's carbon. Anything where incomplete combustion occurs, we get production of carbon, and that can enter the lower atmosphere, and it's obviously a pollutant and also an irritant if you breathe it in. Incomplete combustion also gives us carbon monoxide, and it too is a bit of a problem for humans. Carbon dioxide, whilst the concentration is reasonably low and in the upper atmosphere it forms a nice little blanket, the levels increasing too much creates problems. Now we know carbon dioxide is produced through respiration, but it's also a product of complete combustion. And so these processes can release more carbon dioxide than can be withdrawn through photosynthesis, leaving us with a net excess of carbon dioxide and a resulting rising of those levels and some of the effects that we're already seeing in terms of global warming, and you can already get a sense of some of our weather patterns changing. As I mentioned before, ozone's fairly important too, component of photochemical smog, and we'll look more at how ozone forms and this relationship between oxygen radicals a little bit later in this topic. CFCs are another thing that we will focus on in this topic. We'll look at some of the different halogenated hydrocarbons, and most of these fortunately are no longer being used. They've been replaced by other materials because we know of the negative impact that chlorofluorocarbons have, and particularly their relationship with the ozone layer. But they too can be sources of atmospheric pollutants. So the main things that we need to worry about are what's going on in the troposphere, because that's the level where we have mixing, we have convection currents, and these convection currents are creating mixing. So it means any of the gases or particles that are being produced are cycling around in our atmosphere. And that means potentially that's bringing them to Earth surface on a regular basis, and some of these are have a very bad effect on human health. The major source of atmospheric pollution then, I guess we could put into combustion. The problem with combustion is it occurs in both fixed and mobile forms. So we build big factories, power plants, industrial processes, but we also drive cars around, and trucks and buses and all sorts of other things. And so combustion is occurring both in a fixed environment and also in a mobile environment as well. And it produces the obvious things like carbon and carbon monoxide when we have incomplete combustion, carbon dioxide when we have complete combustion, but also as a byproduct, SOxes and NOxes may be produced as a result of either the high temperatures that are occurring or the materials that are being used, coal, for example, that's being combusted in order to provide the energy to run the turbines in a power station. Particulate matter in the form of soot from forest fires or exhaust from industry is a major problem. Now, particulates can also include things like asbestos. Okay, anything that's a small particle that can get into the atmosphere and potentially that can be breathed into our respiratory systems is a problem. Some of these can exacerbate things like acid rain, but they don't necessarily directly relate to acid rain, but they can also be a factor in things like photochemical smog. And sometimes you can actually see some of these hazes sitting over cities. Metal dusts and concrete are also forms of particulate matter. So these are particulates as well. As I said, anything that is small that can potentially be breathed in is not good. And sometimes we have safety measures such as masks if you're working around an industrial site with a lot of metal dust around. Can be a good way of dealing with that. And other times a lot of this stuff happens outside, and so that rather than being contained, it's allowed to escape into the atmosphere, which makes it safer for the people who are working on the site, but obviously spreads that pollution over a wider area. You can also have gases, vapors, that may be from solvents that are used in industry and also in our homes, can also cause some level of atmospheric pollution. I guess if you're spraying deodorant or perfume around as well, they'll get into the upper atmosphere, they'll get into the lower atmosphere, and we'll also inhale those as well. And that may be a good thing, and that may not be a good thing, I guess, depending on their concentrations and what the alternative is. And I've talked previously about ozone and the fact that in the upper atmosphere it's great, in the lower atmosphere it's a real problem as a respiratory irritant. The sorts of questions that you get from this, I guess, of this type. So a 5-mark question from a couple of years back where we were asked to draw a labeled diagram to show the layered structures of the atmosphere and to include 2 atmospheric pollutants positioned in the layers where the detrimental impact occurs. And we also need to name the sources of the 2 pollutants. So when you go about a question like this, you want to make sure that you're looking at the surface of the Earth, the first level, which is the troposphere, and the tropopause in the middle, and then the next level, which is the stratosphere, and the stratopause here, and then the mesosphere, and you might go on to the thermosphere, and perhaps even the mesopause up here you might label. So make sure you show all the different layers in the atmosphere and then start to identify where the pollutants are. Now we only need to pick 2 of these. So we know that in the stratosphere we're going to have our ozone layer. But this is not a pollutant, so you can actually show ozone in the troposphere. So if we showed ozone down in the troposphere, then that is a pollutant. Okay, and so we then have to name the sources. So remember, for each of the pollutants that you're planning to pick, to ensure that you've identified where those sources are going to be. Some of that is a consequence of the interaction between CFCs and ozone, and also oxygen, and the production of free radicals. Now, this is part of what we will look at in one of the subsequent videos, so I wouldn't expect you to know too much about this just yet, although you may have had a little bit of a look ahead. So what we might pick then as being easier ones to track, link back in with what we've done before. So our SOx and NOx are the easiest things to pick, and you can try and make these questions harder than they actually are. I only need 2 atmospheric pollutants and I need the sources. The easiest way is then to take information that I've already looked at before. I know volcanic activity can give me sulfur and sulfur compounds. I know that lightning or combustion can give me nitrogen compounds. And so this is identifying, because these tend to be components that can be part of acid rain, I know that they're going to be in the part of the atmosphere in which the weather patterns dominate, which again is the troposphere. So identifying that layer in the atmosphere where these are going to be most critical, identifying their sources, and you can identify both natural and human influenced sources. Gives you a good answer to each of these. Make sure when you finished your question, you go back through and say, have I got a labeled diagram? Have I shown the layered structures of the atmosphere as far as I can? I probably would want to put a scale on this as well, 0 at the bottom, 15, 50, and so on. I want 2 atmospheric pollutants. So I've put these here, so you can be specific if you want to with these, doesn't really matter. And position them in the layers where the detrimental impact occurs. So remember that it's positive. Ozone in the stratosphere is positive, but down in the troposphere it's negative. So make sure you're identifying where the detrimental impact occurs, and to identify the sources of your pollutants. Thanks for watching.